Another good application of these linear or inequality problems are to come up with the system after, based off the picture. So let's say we had these 4 points listed here, and there's a quadrilateral which has these 4 points as vertices. Write a system of linear equations that has that quadrilateral as a solution. Explain how you found the system of inequalities. Now that's a typo. I should say write the system of linear inequalities. Alright, so that's what we're going to do. So what I did is I kind of worked backwards. I graphed the picture, and these were the 4 vertices. So how did I get this answer? So here were the 4 vertices that were given. Alright, well I looked for these two, which were on the same vertical line. And since this is the quadrilateral here, this parallelogram with the 4 vertices, I knew I had to shade it to the right. So since it was a vertical line that overlapped with the y-axis, shaded to the right, I knew that x is greater than or equal to 0, had to be one of them. Alright, same thing happened here. These 2 points are on the same horizontal line, and it's over the x-axis, and it's shaded up, so that's how I knew it was y is greater than 0. Alright, same thing happened here with the y is greater than 2. These are on this, or less than or equal to 2. Alright, these are on the same horizontal line, these 2 points, 0, 2 and 3, 2, and it's shaded down, so I knew that, alright, that would have to be the third equation. Now for this last one, it was the line connecting these 2 points. Alright, those 2 points were 3, 2 and 4, 0. So what I had to do was write the equation of the line through those 2 points. Alright, and you could do that by finding the slope between these 2 points. Right, from 2 to 0 is down 2, and then from 3 to 4 is up 1. So the slope is negative 2. Right, then in point slope form, you could plug in a point and the slope, and you could leave it like that, or you could put it in slope-intercept form. Now, to figure out what this inequality is going to be, you kind of test a point. So you have y is either greater than or less than negative 2x plus 8. Now, how do we know what direction? Well, since we're going to assume these are all solid lines, alright, they don't have to be. If they were dotted lines, this would be a less than or greater than sign, not a less than or equal to or greater than or equal to sign. But since I'm assuming these are solid lines, it's got to be greater than or equal to or less than or equal to. Now, which one? Alright, I'm going to test a point, and that point's going to be 0, 0, because it's the easiest point to test. Alright, why 0, 0? Well, like I just said, it's the easiest point to test. Alright, it's also in the shaded region if I were to shade to the left of this line. So since it's in the shaded region, right, it's right there, alright, I want to make sure that it works. So if I plug in 0, I get 0 blank 8. Now I want 0 to be a solution of that, so I want this to be true, which means I want this sign to be a less than or equal to sign, because 0 is less than 8. So y is less than or equal to negative 2x plus 8. So that's why I had that equation right there with that sign. Alright, so just like you test the point to figure out where to shade, if you know where to shade, you can use that idea to figure out what the sign is. Either less than or greater than. And then the dotted line or solid line will tell you whether it's equal to or not equal to.